Hi, I am Oliver, one of the two Olivers speaking here today. I'm Oliver of Monzo. So I work at Monzo. We have these things at the minute. We have these fantastic pink hot coral debit cards. If you don't have one, you should totally get one, but you have to live in the UK for now, unfortunately. We have, about for the last 2 years now, been building a bank. So the prepaid card was kind of a product we could launch without having a banking license. We now have a banking license, and we will launch full current accounts later this year. Kind of what makes Monzo different is, well, lots of things, but on the technology side, we are building the best current account, and that means the best banking app in the world. It has lots of really cool features already, like you can freeze and unfreeze your card with a single tap, you can order a replacement card in the app, you can analyze your spending. Whenever you spend anything, you can actually see where it was, which for most banking apps is fairly revolutionary, because you're used to seeing these sort of cramped 14-character statement descriptors, which, like, if you've seen them in the UK, it's often very difficult to figure out where you've even spent money when you look at your transaction history, which is, to me and to us, fairly embarrassing. Whenever you spend with us, you get kind of a very clear idea of where you've spent. So here you can see I've spent £14.99 in a shop called Tiger. Whenever you spend anywhere, one of my favorite features is you get emoji with every transaction. A surprising amount of our back-end code is dedicated to choosing the right emojis. So we take this quite seriously. Longer term, our kind of big vision, oh dear, what's happened to my emoji there, is to basically improve people's relationship with their money. In the future, we want, we have quite a big ambition to be all over the world. We want to be basically at the center of people's financial lives. To date, we have about 150,000 cards issued. These are prepaid cards over the last year, so we're growing quite quickly. And as I said, later this year, we will launch the current account. And one of the things that will kind of not be a feature of the current account is a waiting list. At the minute, there's a reasonably large waiting list for the prepaid card. Running Monzo and building Monzo involves an interesting tension in that we are both a fast-paced tech startup, and that's not something we want to lose, but we are also a highly regulated retail bank, and that has a lot of implications for our technology. While we want to use the best technology, and that often means very modern technology, like Kubernetes, we need to be able to kind of defend it and make sure we're using the right thing for the medium to long term. And we have a few sort of set of requirements, these will probably be fairly familiar to people, that we want from our technology, and that is that it should be extensible. In the future, as I said, we'll be operating kind of around the world. At the minute, it's just in the UK, but we have plans to move beyond that. All around the world, there will be a different set of regulation, that most places we will be highly regulated, but differently regulated. We'll be connected to hundreds of third parties. We're already connected to a very large number of third parties, things like payment schemes, things like MasterCard and faster payments in the UK, SEPA in the rest of Europe. In the future, there are others like ACH in the US, and then also other things like identity providers. So, we need to be able to assert the identity of our customers, and that involves connecting to a reasonably large number of third parties as well to get information about our customers. And there are a bunch of others. We want things to be efficient. We are a startup. We don't have infinite money like most other banks, and money is fairly expensive when you're funded by the venture capital community. We want things to be resilient. One of the things that we kind of hold most dear is our customers' ability to be able to use their cards all the time. We had a fairly large outage recently, which we're not proud of. That was, and we're sort of taking steps to remedy that, but kind of one of the things that are most important to us is customers can use their cards at all times, even if other parts of the service are having problems. And being connected to hundreds of third parties means that inevitably there will be parts of the service more or less at any point in time. And we want things to be secure. I got a question about this earlier, and this isn't the focus of this talk, but as a bank, you are a very high value target. People can spend very large amounts of resources targeting you, and we need to kind of be one step ahead of that. This kind of led us to a microservices architecture. So we have I think we have upwards of 200 services in production at the moment. That's kind of unique services. There are thousands of instances of those services. And each of them are kind of small, decoupled units that do a single thing and, hopefully do that single thing well. Like I mentioned, emoji is one of those very important things. Docker and Kubernetes are something we moved to toward the middle of last year. They do a really good job of kind of packaging and running these applications. We have a fleet of machines. We want to schedule our services, replicas of those services, across those machines. This has been a really kind of big win for us, as well as packaging our own services, which are generally stateless microservices. We've also started to move increasingly other bits of technology in there as well. So stateful services, we are putting Kafka in there at the moment. We also run things like RabbitMQ in Kubernetes, which sort of in the first instance sounds not a very good fit, but we've actually found it's a great way to run those things as well. When we first moved to Kubernetes, we kind of immediately, not sure what's happening there, saved 60% of our infrastructure cost. Oh dear. This doesn't. Oh dear. Okay. Anyway, we're just going to have to bear with this. When we moved to Kubernetes, we immediately saved 60% of our infrastructure cost, and that was about 6 months ago. Since then, our per user infrastructure spend is we've saved about 80% of what we were spending before then per user, which we think is pretty great.
See the picture? Keep talking.
So one of the things we need to deal with a lot in an architecture like this is communication between services. As I mentioned, Kubernetes does a good job of running these services, but communication between them is really important when you have thousands of things and all of them basically need to talk to other ones. A single request, yes, well done, Oliver. A single request that comes in via our API can easily fan out into tens or even hundreds of requests internally. So that kind of part of the system is really important. Kubernetes has the concept of a service that really only solves the service discovery part, and it turns out you actually want an awful lot of things in the layer that manages communication between services. These are a few of them. We previously had an RPC system built atop RabbitMQ, which relied on kind of a large in-process library. It solved some of these problems. It didn't solve all of them. It was difficult to maintain, and it sort of tied all of our services to running in this one language. I mean, nearly all of our services are written in Go, but we do have things now that are not written in Go, and kind of if you have one library that you have to replicate in N languages, that does not scale well. So what we use for this now is we use Linkerd, which basically sits between all of our services. It's out of process, which means that kind of as long as our services can speak the RPC protocol, which is HTTP in our case, which obviously basically every language can, they can talk to other services and don't have to worry about all of those concerns that I kind of listed there. So yeah, over to Oliver to talk a bit more about Linkerd.
Alrighty. Who here before today has heard of Linkerd? Excellent. So I'm not going to ask you to tell me what it does, but who here has tried Linkerd? Maybe that is another good question. Okay, by the end of this talk, I hope more of those hands want to be up, and maybe next time we talk, more of those hands will be up. So Linkerd, in our mind, is what I think of as a layer 5 load balancer. And we say layer 5, we're talking about the OSI stack. So over the top, we have the banks code, right? The banks need to be focused on emojis, apparently, and transactions and all of these things. And they shouldn't be really tied to any details about where they're running. They shouldn't have to know about Kubernetes or services. Sorry about that. Is that better? Yep. Sorry about that. They shouldn't have to know about pods or services, or if they're not in Kubernetes, they shouldn't have to know about Zookeeper or any of the kind of service discovery details behind the scenes. Similarly, down at the bottom of the stack, we have cloud providers and data center providers. And these people really shouldn't have to know too much about the workloads that are running on them, right? We want to just be able to provide generic pieces down here, up until we're talking about layer 4 TCP connections. And in my mind, the job of Kubernetes is to get you listening on a socket somewhere. And at the top, we have do the business. And there's a bunch of glue stuff in between. And that last slide Oliver showed, we see a lot of concerns that aren't solved by the lower half, nor should they really be solved by the top half. And that's where Linkerd comes in, at layer 5. And I should note, at the end of the talk, I'll mention that we now have TCP support in Linkerd as well. But first, let's step back and think about linking. We all know linkers from back in the day, right? LDD and such. And what a linker does in that model is, you're building a software artifact, go find all my dependencies and pull them in. If I depend on, I don't know, libc, where is libc? Go find me that artifact. It's a pretty old idea. And so we're talking about names and addressing. Before we go further, I want to just step back and think about this a little bit, right? So at layer 3, back 40 years ago, we invented TCPIP, or Vint Cerf and Robert Kahn invented TCPIP. And what that gives us is, the kind of evolution of how we manage that was an etc host file, a list of host names and IP addresses. That's the original service discovery. And beyond that, we had a list of service names and ports. And these are checked into every box in the world. And can you imagine running Kubernetes if it still worked that way? No. Brief aside, I want to point out that up until Windows 95, building a TCPIP stack was a business model. This wasn't commoditized and freely available. So it's changed a lot. And we're going to see similar things in our space now. Moving on, another 10 years after that, so 30 years ago, we finally saw DNS. This copying etc host files around between universities was just not scaling as the number of computers came up on the internet. So we needed some infrastructure to support that, something out on the net where I could say, hey, where is this thing? Give me some actual bound address for this logical name. Moving forward, we still have this, right? It's just a lot more automated, a lot easier. So in Kubernetes, we have services. Services give you this very easy abstraction where I say, service A is composed of all of the pods that are labeled app A and none of the other pods. It's really easy, but it's also pretty fragile in a microservice where you're moving quickly. I mean, I'm not bashing it. I'm just saying we can do better. And so what would a linker look like in a cloud-native environment? Especially when we have multi-tiers of calls, right? So things come in through some front-end feature set, and they get routed down to your user service. Every big system has a user service that everything talks to. And it's impossible to stage new versions of it. So if I want to stage a new version of the user service, how do I get all of the things that talk to me to talk to that new version of the stage service? It's hard, right? In the Kubernetes service model, I can't really do that. I either have to put something into production and serve real production traffic, or have a whole kind of replicated other staging environment of the full stack. And if I'm on one team that owns a user service and these are all other teams, that takes a lot of coordination to do, or a lot of either that or you have a really kind of iron-fisted operational model. So what Linkerd introduces is this concept of logical naming. And every request that goes through Linkerd is identified with a name. And so in this case, we'd have service users. That's what Linkerd sees, or that's what the application knows about. I'm sending something to the user service. And that could be, go look this up in Zookeeper in the prod namespace. Or it could be, go look this up in Kubernetes in the staging namespace with the HTTP port. The details of this really shouldn't be bound in the application at all. In fact, I may want to run these environments simultaneously. Maybe I have a legacy system, and I need to do service discovery across both things. Encoding that all in the application is really burdensome. And so what we have is a way to write delegations. And I can say, when you would go to route service, go look in Kubernetes in this way, or go do a union, or go fall back. It's a really powerful language here. Some examples of that. We can use this to do things like per request overrides. So I can set a cookie in my browser that says, when you would talk to the user service, I want you to talk to my version of the user service instead. Anything in the call graph that's going to talk to the user service, go talk to this other version of the user service instead. Before starting Buoyant, I worked at Twitter.com, and this is how we solve staging. If I'm back 5 levels in the call graph, it's very hard, it's very fragile and manual. And so we introduced something where, as an engineer, I can just go tag my requests in my browser with certain behaviors, and that works. We can also use this for something like Dtrees, where I want to intercept calls across the system for some debugging thing. And maybe this debugging thing is actually expensive to run, so we don't want to run it on all requests. So I can either, just on my requests from my browser, have things route through this proxy, then they'll forward to the normal service, or I can manage this centrally via what we call Nameerd. The other kind of really big feature that we're stuck with is that we want to see what's going on in the traffic. We really care about success rate, and I want to be able to know whether a service is an SLA or not. I also care about latency, whether the service is an SLA or not. I also care about tracing and who's talking to whom and being able to visualize that descriptively, not just what's in the config files, but what's actually happening in the system. And I want to do this in a way that doesn't bind us, again, to specific libraries. So if I have this really working well in Go, and then we acquire a company that has a bunch of Node stuff, how do I replicate this exact set of features and get this so that we're measuring success rate properly? It's actually hard to measure success rate uniformly across different implementations. And so Linkerd exports many, many stats by default. So just by sending traffic through Linkerd, we get a lot of runtime information exported. This is a project called Linkerd Viz on GitHub under the Buoyant IO repo. And this, what it does is it just scrapes Linkerd stats. It can find all the service names from them and generate a dashboard for free. So there's literally, all you have to do is configure Linkerd, deploy this thing to talk to Linkerd, and you get a dashboard of success rate and latency, et cetera, for free. And this is Grafana, so it can be modified pretty easily. Similarly, you may have heard of Zipkin. My team at Twitter open sourced this in, I think, 2012. And this is the call graph at Twitter in 2012. This is not supposed to be very informational. It's supposed to show you that it's super complex. But also that how hard it is to reason about interactions in a distributed system. When we have this many services and this many staging versions and n, how do I know which services are actually communicating? Managing this only through configuration is not practical because it's not real. We want something that the system can just tell us. And so Linkerd will emit Zipkin traces if you forward some headers through your application. So your application doesn't have to be instrumented with lots of tracing specific things. It can just say, oh, just send this context through, and with that, we can get tracing for free. On the operational side, and I think this is what Oliver was talking about before, we have things like timeouts and retries. And so we always start our system by just choosing some numbers, right? I want 3 retries and 400 milliseconds sounds good. And then another team makes another decision. Well, I only want to do 2 retries. And we can maybe get this together if we all sit in a room and talk about it. But as the scale of the system grows, it becomes really hard to compose these things. Does anybody see any problems here? Or any arithmetic people in here? These aren't composable at all. If we fail anything anywhere else and have to do a retry anywhere lower in the stack, the top timeout fails. So this is all for naught. The top timeout is the only one that matters. Well, how do we fix that? Deadlines are a feature that we can implement in Linkerd. We propagate them but don't act on them at the moment. But this allows your application to instrument timeouts based on the deadline. And what we try to do is set a timeout on a feature. So rather than thinking about timeouts on a service, if this service has this much latency, I want to think about the feature, the look up the emoji feature. How much resources am I willing to give to that request? And maybe the transaction feature I'm willing to give more resources to. So I want to set different timeouts on these things. Or OK, if we don't get an emoji, that's fine. Time it out quickly. If the transaction's taking a while, we really want that to succeed, so maybe give it some more time. And we want to be able to set that again on the highest feature and not on the service internally. Retries are another really interesting thing. We've all probably, anyone who's written a service that talks to another service has had to think about how that fails and what to do when it fails. And usually what you do when it fails is you just try again. Maybe you back off. If we are in an incident where things are really failing, what we've done here is made an error cannon. I've now magnified the load on my system when I most need it to reduce. And so if we have a hot database, we're just slamming more load on the system, and we need a solution to this. Finagle, what Linkerd is implemented with, introduced retry budget. And a retry budget lets us think about the amount of capacity we're willing to absorb or to provision, over-provision for incidents like these. And so if I say 20% retry, well, I'll only add 20% more load. And this makes it a lot easier to think about provisioning my service to start for the worst case. We also care about load shedding. So when timeouts may happen somewhere in the system, what if I'm doing thousands of database calls, and we're doing all this work, and the timeline service is never, ever going to get the response? It doesn't care. It's timed out. It's gone to lunch. We have a new deploy going. But this thing's still working. Well, what we need to do is be able to propagate timeouts down the system. And so we can do this in HTTP by just closing the connection and having this connection close propagate. In HTTP2, we can do this via explicit stream cancellation, which is a very nice feature. Finagle also supports this protocol called MUX, which has this built in as a first-class citizen. Backpressure is another really important strategy here as well. So if we have lots of load on the top of the system, but this database, this poor database, just can't keep up, what happens? Well, the user service melts down. If it's written in the JVM, it goes into some GC spiral and never comes back. And meanwhile, requests are just failing all over the place. And it's actually really hard to recover from this, because we're failing low in the stack. And our goal for Backpressure is to push problems as high up as we can. And so if we can only satisfy 100 here, this user service shouldn't accept any more requests. And it should, in fact, be able to tell the timeline service, don't request anymore. With HTTP2, this is, again, a built-in feature via flow control. With HTTP1, Finagle has some special provisions for this sort of thing.
Sorry.
Yeah.
You have all that already in what you're talking about?
You don't believe me? Yeah, this all works in Linkerd. Yeah. And the goal here really is that we want to be able to signal things back up to clients if we can. So if I'm failing here, maybe I want to fail over to another region, and I want to have the top of the stack be able to make this decision. We don't have automatic failover built in yet, so we're working on that still. But yeah, we want to be able to force this back even to the clients if we can, so that we can always go to another region. These decisions are best made higher up the stack. And my favorite feature of Linkerd, maybe not favorite, I think the most important feature of Linkerd is request-aware load balancing. And so you're probably familiar with round-robin load balancing, what's in kubeproxy by default. And in that case, you just pick a node, 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 pick a node. And that can be very bad when one node starts failing. And so in this example here, this is a test we ran where we had a 1-second timeout set talking to a 10-node cluster, and one node starts timing out. If I'm using round robin, I am about 95% success in that one situation. Everywhere I've been on call, that's a wake me up success rate. And I really, really don't like to be woken up. It's kind of my motivating factor in life is to not be woken up by computers. That's why we're working on this. And so we can change that. We can add least connections, and that moves up a little to about 99%, which is pretty good. But usually we care about a little bit more success rate than that, especially in a web scale service like Twitter. And so Twitter developed an UMA load balancer, exponentially weighted moving average. It also uses this very fast power to choices. Apparently there's this math that proves, the way that load balancing was initially implemented was a heap. We keep a priority heap of the number, by weight, an order thing. We always take it off the top. That can be quite expensive to manage. And so power to choices, we just pick two nodes at random and compare them. And that's equivalent to keeping an ordered heap. Amazing, random numbers. So with UMA and power to choices, we're able to push this up over 3 nines. And so that's just a config change in Linkerd or in Finagle. We can improve success rate. This has real world improvement. So beyond success rate, this means you can move things a lot more quickly. So certain services would take, I'm not exaggerating when I say more than 12 hours to deploy, because we'd have to be very careful in rolling them one at a time, letting them warm up again before we roll the next thing. By using UMA, we're able to punish things inertially and say, OK, I haven't sent any load to you. I don't know what you're doing. I'm going to send you very little load. And as it improves, we increase it. And if there's an error, if there's a latency spike, we back off dramatically. And so the whole point of UMA is to, because we're looking at the individual request response latency, we're able to make better decisions. And this is something you cannot do in a pure TCP load balancer, right? If I'm at layer 4, I don't know about request latencies. If I'm at HTTP, I know when I get a request and I know a response, I can measure that time and use that to inform load balancer. Furthermore, Finagle just made Aperture load balancer default. We're considering that in Linkerd. We're unsure about that at the moment. The goal with Aperture is to limit the number of nodes I talk to at once to fit my load. So let's say the user service, because it's used by everything at the company, has 1,000 nodes. But I'm running this one little side project, and I get about a request a minute or something like that. Well, if I'm, maybe let's say I'm getting about 1 request consistently, 2 requests consistently. If I'm load balancing over a 1,000 node cluster and I'm picking 2 at random every time, I have no load information. There's no information to make the decision because nothing's loaded, right? 998 of them aren't loaded. And so what Aperture does is it constrains the number of nodes I select from to fit my actual load requirements. And as that load increases, I select for more nodes. And then that selection scrolls over the set of nodes over time. And this is a really effective tool. I just really want to hammer on the point that load balancing at the request layer lets you do a lot more than you can do in a pure stream system. So some history of Linkerd for those of you who haven't heard of it. We donated it to CNCF in January. That was a pretty big milestone. We initially announced it in February of last year. I first talked about it at KubeCon EU last year. Anyone there for that? Yay, hey. And it's been a long road since then. We've added a lot more features. We've been helping a lot of both small and large companies go to production with Linkerd on Kubernetes, on Mesos, on some combination of the two, on other things. There's everything under the sun out there. Recently, we've been doing a bunch of work. We just shipped Ingress support. So now Linkerd can be configured to consume Kubernetes Ingress API to do routing. I spent a bunch of Q4 working on HTTP2 in Linkerd. So now we have a pretty decent, I hope, HTTP2 implementation. We have a gRPC implementation as well, meaning we can do code gen for Linkerd, so Linkerd can talk to services. And that's what we're using for some of our new APIs. So we have Namerd as our central route manager, now has a gRPC API we just shipped. We just shipped this week a new plugin API. So Linkerd is very pluggable. You can use things that we provide, or you can write your own plugins if you want. We just shipped one that controls client policies. So up until now, you've only been able to set a timeout on the whole router. Now I'll be able to set timeouts and retry policies on a very fine grain, on a per method thing. Yes, question?
Yeah, questions regarding HTTP2.
Yes.
So, do you have some experience with nasty enterprise network devices like firewalls, blue code, this nice stuff we have to live in the real industry? Or?
I mean, I've certainly. Well, OK, so is the question whether HTTP2 works in those environments? Or what's the question? I mean, HTTP2 generally works in these environments because it's TLS. The HTTP1, there's a lot of nasty middleware, as you know, which breaks HTTP and tries to inspect HTTP. And so this is why HTTP2 is TLS by default, is so that these things can't even pretend to look at them. And so they just see them as a secure stream. How your particular enterprise deals with that is a matter of policy. So HTTP is no silver bullet. It's still quite new. And I have to be honest, most of the implementations I read don't implement it properly, especially around flow control. No offense, Go users, but watch out. Yeah, so but most of our users right now are on plain old HTTP1. We do, for a lot of these users, install TLS. I mean, we have not run it against these specific names you've used, but Linkerd supports open protocol. So it supports HTTP and HTTP2. And if your middleware supports those things, then it'll work. What's that?
Always on paper, everything is.
Sure, yeah. I mean, yeah, the devil's always in the details. I am quite happy to announce that we're marching to 1.0. We will be shipping it in April. I think we're cutting RC1 today or tomorrow, San Francisco time. And I encourage any of you who are interested in Linkerd to go test it, give us feedback, tell us now's the time to get in before we hit 1.0 and we're stuck with it. So please give us input. OK, this I'm really happy to talk about. I just pushed this thing to the public GitHub on Monday, so it's brand spanking new. But for all my bashing of TCP, there are a large number of applications that have weird protocols. Either weird databases or weird enterprise things. And we still want to be able to talk to service discovery and abstract service discovery in the same way, and we want to be able to install TLS outside the application in the same way, and we want to do some level of request level or of stream level load balancing. We can't do request level load balancing here. So we implemented a TCP load balancer in Rust. Any Rust users out there? Not yet. Talk to us in a year, there'll be a lot more hands. Rust is a great language, it's native, it's safe by default. It means it's very fast and very tiny. I would love more input and use here. Whoever raised their hand back there, please come give us feedback, test it out, submit pull requests. This is a new project, and we're going to be spending a lot of time on it coming up. So that brings us to the end, quite a bit early. So I want to open this up to questions for the both of us. I know there's probably more questions for the other Oliver, because he's running a business, and I'm just talking about technology, but yeah, have at it. Up front.
You mentioned egress support. Right now there's only the engines, but then egress default is just an X controller. Google local thing. So are you considering putting it as default egress?
We would consider it. I have to be honest, the Ingress API, from our experience, is underdefined right now. There's a lot of unspecified behavior, and the way to figure out what the Ingress API actually is looking at traffic and Nginx to see how they've mapped it. I personally would like to get a little bit clearer on the support before we say that it fits what the Ingress model is. But yeah, I think we'd be totally open in getting this in a default distribution. Yeah. Question here. Next release of Linkerd. It's a totally separate project from Kubernetes. It works well in Kubernetes, but it works very well everywhere else as well. One of the real goals of Linkerd is to bridge that gap so that you have a common set of communication tools that aren't bound to the orchestration layer. Question back there.
What percentage latency do you add by doing all this interception mapping up?
So the last load tests that I remember are 3 or 4 nines is 5 milliseconds. I think 4 nines is 5 milliseconds. It can be worse in some workloads, so it's workload dependent. So please, if you test this and find problems, let us know. And we actually have a blog post on blog.buoyant.io that shows that we actually reduce latency in many cases. So when you're talking to or when you're talking to a slow cluster or with slow actors, we can improve latency substantially. Question back up here.
So maybe you showed 2 parts. One is the bank and one is Linkerd.
Yeah.
You didn't show the integration. How do you use this?
Yeah, so all of the RPC between our services uses Linkerd. That doesn't mean that all communication in our platform uses it, but all of the RPC between services, which is 90% of the communication in our platform, goes through Linkerd.
And so specifically, there's a blog post on this that Oliver did a lot of the hard research here and gave us a solution. We've written many blog posts about it, but we deploy Linkerd as a daemon set. And so there's one Linkerd instance per node. The node has this hack. It can use the downward API to discover the local Linkerd address, the local pod IP for Linkerd. So everything locally gets sent to localhost on some local Linkerd. Linkerd does the discovery to find out either what service it's sent it to. We don't use DNS. We use the endpoints API directly. And so what feeds the DNS?
Yeah, kubedns is a consumer of the endpoints API. Linkerd talks to the endpoints API directly.
But your clients need to be adapted to it.
So clients need to know where their local Linkerd is. The way it looks is they send a request with the host header of the service they want to talk to. They send it to their local Linkerd. And the process of finding the local Linkerd is interesting, and that's what that blog post is about.
And the way we usually instrument that is via the HTTP proxy environment variable. So most frameworks support HTTP proxies. We can treat Linkerd as an HTTP proxy. So this works in most frameworks with very little code change.
But it needs potentially code change.
Very minor, yeah.
Yeah, especially if you want context propagation, you need code change. But for the discovery aspects, we can do this in many cases without code change. Question in the back on the left first, and then I'll come back up here.
Yeah, is the Linkerd D and the Linkerd TCP stackable, separate instances, or
Right now they're separate. Like I said, we just launched Linkerd TCP this week, so I'd like to get them to be able to run together so that we can, for instance, terminate TLS in the native side. And yeah, this is evolving still, but they're separate at the moment. I expect they will get closer together over time. Question back here.
Would it it make sense to take all outgoing traffic from something, whether it's a VM or a Kubernetes pod or whatever, and just take all of it and put it through Linkerd TCPIP, for instance?
That could very well. Depends on what you want out of that, right?
Because what I want is for it to not be able to speak outside of the RPC system, right?
Yeah.
Like you cannot connect to,
Yeah, so we have some people doing very similar things, not with TCP, but with Linkerd, where you can just send everything through here, and then via the route control what goes where. You can also ensure that everything that leaves is TLS'd and verified and all that. Yeah, that's exactly right. Anything on this side of the room? I've been standing over here. Question in the middle? Yeah.
it's a question about enable Linkerd. What's the preferred way of using Linkerd?
If you're already running Finagle, what's the preferred way of using Linkerd?
Yeah.
That's a good question. I mean, you can treat Finagle as anything else if you want, right? It's just an HTTP library at the end of the day, so you can just have it send through Linkerd. Depends on what features you want out of Finagle and Linkerd. There is a bunch of overlap there, so it may not make sense to run Linkerd in that case, or maybe only make sense to run Linkerd for the non-Finagle things, or maybe it makes sense because you want to have some policy layer that's outside the application. So it kind of depends on your requirements. I'm happy to chat more about that, though. Anything here, front?
A question for Oliver one. Just
Hey.
about what's next for Monzo? You're obviously bringing in current accounts. I imagine that's what it calls.
Yes, so the current account will be launching later this year. When we launch the current account, we will be migrating all of our customers off the prepaid card and onto the current account. That won't happen overnight, but that will happen. The current account is a full bank account. So currently the product is a prepaid card that you load with money from another bank account and then spend it like you would use a card in any other shop, but you cannot make bank transfers. You cannot get your salary paid into it. You can't pay your rent out of it. You can't get an overdraft either. Those will all be features of the current account that are not features of the prepaid card. So basically the distinction is with the prepaid card, technically another bank is holding the money. We are it's sort of presented through the Monzo app, but there is someone else behind the scenes holding that money. We will we will hold the money directly when we launch current accounts.
In the back. You're done? Yeah.
Was that your whole question? What's next for us also is expanding internationally.
Okay, yeah. So is it sort of code that you've already kind of got on the back burner that you're waiting to release onto your
For a lot of the current account stuff, yes. For international stuff, yes and no. So obviously there is a large kind of portion of our backend that will be shared across all countries, and then there are a number of integrations that will have to happen in each country, and they will be unique to those countries.
How many countries are in it at the moment?
One, just the UK.
There's a question back there, yeah? Hold on, just hold up. One more time.
The question is whether we do our own processing, as in card payment processing. Currently, we do not do our own card payment processing. When we launch the current account, we have connected directly to MasterCard. That's not used for the prepaid card, but that is how the current account works. So we are both an issuer and a processor of the current account. Is the question about what an issuer does? Sorry. Right, so for the prepaid card, two separate companies that are not Monzo are the issuer and the processor. When we offer the current account, we are both the issuer and the processor. The issuer being the person who holds the funds and who's basically legally responsible for them, and the processor being the person who's connected to MasterCard. We're both of those things. Any other?
Question back here? Yep.
How big do you think the gRPC solution is?
It works well. We don't have any known bugs with it, so please find some. Basically, like we have people who are working towards prod with it today. I know there are some feature deficiencies in the gRPC solution right now. For instance, retries are hard in gRPC because they're at the end of the stream, the status code. So there's some wrinkles to work through still. But as far as the HTTP2 support generally, no known bugs. Please find some. I also have Linkerd stickers if anyone wants stickers, or just come ask questions up here because people are filing it now. Thank you very much.
Thanks.